Hello. Yesterday we talked about what is a function, what is a relation. Today we're going to talk about more specifically those linear functions at the end of our notes. So I showed you how to identify it if it's a graph. If it looks like a line, it's linear. And there's only one type of line that's not a function, and that's a vertical line. So today we're going to talk about how to identify them without a picture or without drawing a picture. So a linear function in a linear function, a constant change in x corresponds to a constant change in y. So I'm going to show you what I mean by that. So we have to figure out what is the pattern, what's happening to our x's, and is it the same? So here, plus 1, plus 1, plus 1, plus 1, those are all the same. Here I'm doing minus 3, minus 3, minus 3, minus 3, and all of these are the same. So this is linear, because my x pattern is the same and my y pattern is the same. So if I take a look at my x's on this one, it looks like it's doing the same thing where we're doing plus 1 each time. And you do have to check each one on your table. If we look at our y's here, it looks like I'm going down 3 and then down 1, up 1, and up 3. This is not constant. We would not consider that constant. So this is nonlinear. So this is still a function. None of our x's are the same, but it is not a line. So let's take a look as if we had a list of points. It still works the same, and if you want to organize them in a table, you can. But I'm going to look at my x's first. Looks like I'm doing plus 3, plus 3, plus 3. And now I'm going to look at my y's. Here I'm doing minus 1, minus 1, minus 1. So this is linear. Here I'm doing plus 5, plus 5, plus 5, minus 6, minus 2, minus 2. So this is not constant because of this first minus 6. So this is nonlinear. All equations. So we did graphs yesterday. We just did tables or a list of points. The other form is equations. All equations in the form y equals mx plus b are linear. And we'll get into more of what m and b stand for later on when we focus on just lines. But this is slope-intercept form of a line, just FYI. So if I can rewrite any equation into this form, then it's a line. Here, y equals 3.8. That's a line. And I know that because I could have 0x plus 3.8. Okay, m and b would be numbers like y equals 2x plus 1, for example. Here, I have this exponent of x. That disqualifies it. It is nonlinear. Here I have x in the bottom. That's also not allowed. I cannot divide by x, so this is nonlinear. Here, let's go ahead and distribute. I would have y equals 6x minus 6. That's the same type of form. So it is linear. Square root of x, also not allowed to happen. So this is nonlinear. This exponent of 2 on my x, not allowed. This is also nonlinear. So really what you're looking for is my y or my x, does it have a coefficient that's a whole number or a fraction or a decimal? That's fine. But if I have a square root, an exponent, if it's on the bottom of a fraction on my x or my y, then that's not allowed. So it has to be just a normal y and a normal x in your equation. Discrete, we're going back to a little bit of what we talked yesterday. Discrete is a set of input values that contain only distinct points. They're just points kind of floating out in space. And they can have a pattern by all means, but they're just the points. Continuous is when we have them and they are connected. So even these are just some points on a coordinate plane. If they're connected into a line, then that's considered continuous. So now we're going to put these into some real world scenarios so you can get a better feel of why there's a difference. So y equals $15.95 x represents the cost of tickets for a museum. Each customer can buy a maximum of 4 tickets. Identify the domain and range. Is the domain discrete or continuous? And this second question, is the domain discrete or continuous, really depends on, can you buy more than a whole number of tickets, really is what we're talking about here. So if you're talking about something that you purchase, normally that's discrete. If you talk about people, that's always discrete. You can't buy 2.5 tickets. You could buy 2 tickets or 3 tickets. You can't have 1.5 people. You can have 1 person or 2 people. So usually if it involves people or something that you can purchase, if it has to be a whole number, then that's discrete. So for this one, I'll get rid of my line here. It is discrete. Now my domain, it says each customer can buy a maximum of 4 tickets. So my options are to buy 0, 1, 2, 3, or 4 tickets. And I would write it in a list like this from our notes yesterday since it's discrete. My range, 0 tickets is $0, 1 ticket is $15.95. Let's grab a calculator here. 2 tickets would be $31.90. 3 tickets would be $47.85. And 4 tickets would be $63.80. So that's my range. All right, so that's a discrete example. Next, we'll look at a continuous example, and we'll talk about why it's continuous. So I already told you this one is continuous, but now let's actually go through the problem. Here it says the number y of calories burned after x hours of rock climbing is represented by the linear function y equals 650x. So when you're rock climbing, you're burning 650 calories per hour is what they're saying. So the reason this one is continuous is that you can work out for more than just hour increments. It's not you have to work out for 1 hour or 2 hours. You can work out for 15 minutes. You could work out for 30 seconds. There's a wide variety. And whenever you're dealing with time, there are some very small exceptions, but when you're dealing with time, it's always continuous. So if you're dealing with people, it's always discrete. If you're dealing with time, it's always continuous. If you have a mixture of the two, you might have to read your problem a little bit closer. But time is continuous. So here, I know it's continuous. When I do my domain, I'm going to have to use those compound inequalities. So I can't work out for negative amounts of time, but I could work out for no amount of time. So I'm going to say my lowest amount I could work out is 0. And then I'm going to set up my compound inequality, but I could work out, not realistically in reality, could I work out without stopping to eat or sleep or do something else, but there is really no upper limit on that. So I'm going to put up to positive infinity. Okay, so a sideways 8 is how we draw that infinity. For our range, if I work out 0, I'm burning 0 calories. So that would be a 0, and then I use y for range, and then infinity, an infinity amount of time is going to be an infinity amount of calories. So our domain and range end up being the same, with the exception of this has an x and this has a y. All right, so that's the end of our notes for today. You do have a big ideas assignment to work on again.